What is programming logic? The monkey thinks the computer is brilliant. He stares at the glowing box and imagines, this thing can think. This thing knows everything. This thing will give me endless bananas. But the monkey is wrong. The computer is not smart. It has no ideas of its own. In reality, it's the most limited creature in the jungle, like a huge gorilla made of silicon and wires. He is strong. He is fast. He can carry 1,000,000 bananas in the blink of an eye. But he doesn't think. He has no brain. If you tell the big gorilla to swallow a rock, he swallows it and breaks his tooth. If you tell him to throw all the bananas into the river, he throws them away. And the monkey goes hungry. The monkey gets frustrated. He yells at the screen. He smashes the keyboard. He copies code from the internet, believing it's some kind of magic. But the monkey doesn't understand something essential. Language. The monkey speaks ooga booga. The silicon gorilla understands only zeros and ones. On or off. Banana or no banana. For these two to communicate, there must be a translator in between. That is what a programming language is. Python, Java, or JavaScript are not magic. They are just dictionaries that translate what the monkey wants into something the robot can obey. But knowing the dictionary is useless if you don't know what to say. The problem is not the machine. The problem is the monkey. He doesn't even know how to speak monkey. Or rather, he doesn't know how to think logically. When the monkey hears programming logic, he gets scared. He imagines advanced math, complex calculations, counting every hair on his arm. But that's not it. Logic is just one thing, a recipe. Imagine you want the big gorilla to peel a banana for you. Sounds simple, right? The monkey says, "Gorilla, peel the banana." And it fails. Why? Because that's not logical. Peel is a vague command. The gorilla doesn't know what the peel is. He doesn't know what the fruit is. To talk to the machine, the monkey must break the action into small steps. Steps so simple that even a rock could understand them. No. So let's build the logic so the computer gorilla can understand. 1. Grab the banana with your right hand. 2. Hold the other end with your left hand. 3. Pull that end down until the white part appears. This is an algorithm. Algorithm is just a fancy name for a step-by-step process designed to avoid mistakes. When the monkey understands this, he stops being just a user and becomes a creator. But pay attention, order matters. If you swap the second step with the third, the gorilla pulls nothing and only then grabs the banana. Result, banana on the ground. Let's test it. Logic is sequence. The computer reads from top to bottom, line by line. It doesn't guess, it obeys. Let's move to practice. The first step of logic is knowing where to store things. The monkey has 2 hands. If he's holding a banana and a coconut and wants to grab a watermelon, he gets stuck. In programming, the monkey needs boxes. We call these variables. A variable is like a box with a label. The monkey creates a box and writes on the label, "Afternoon snack." Inside that box, he puts the banana. Now his hand is free. The computer works like an infinite warehouse of boxes. You can have a box called monkey age and store the number 5 inside it. You can also have a box called monkey name and put Michael inside it. But here comes an important detail that many courses don't explain very well: the type of the box. You wouldn't put water in a cardboard box, and you wouldn't put a rock in a paper bag. In logic, there are types of bananas. Type 1, the integer. It's the whole banana. Exact numbers, no pieces. 1, 10, 500. Type 2, the floating point. It's the bitten banana. Numbers with pieces like 2.7 or 6.28. If you try to put half a banana inside an integer box, the gorilla rounds it and throws the rest away. Type 3, the string or text. It's the word banana written on paper. The monkey can't eat paper, and if you try to add the word banana to the number 42, the gorilla short circuits. Type 4, the Boolean. This is the most important box of all. It's very small. Inside it, there's room for only one answer: yes or no. True or false. The monkey is hungry. If it's true, the gorilla cooks. If it's false, the gorilla goes to sleep. But be careful. The big gorilla is literal. If you create a box meant for numbers and try to stuff a huge text inside it, you'll get an error. Logic is organization. A disorganized monkey loses its bananas. An organized monkey creates variables, stores values, and uses them when needed. Without boxes, there is no memory. Without memory, there is no story. Now imagine the monkey got rich. It doesn't have 1 banana anymore. It has 1,000 bananas. Is it going to create 1,000 boxes? Banana 1, banana 2, banana 3? No. The monkey would go crazy writing labels. That's why arrays, or lists, exist. Imagine a huge shelf with numbered slots. The monkey calls this shelf banana inventory. Then he tells the gorilla, grab the banana at position 0. Yes? 0. In programming logic, counting starts at 0. If you ask for banana 1, the gorilla grabs the second one. If you ask for position 0, he gets the first one. Confusing? A little, but just accept it. It's easier that way. The list helps organize the mess. Without lists, Instagram wouldn't exist because each of your photos would be like a banana on a huge shelf. Now the monkey has the banana in a box or in a list. He wants to eat it. A careless monkey eats anything and ends up with a stomachache. A programmer monkey uses the most powerful tool in the jungle, the if statement. This is decision-making. The code would look like this. If the banana is yellow, then peel it and eat it. Otherwise, which we call else, leave the banana on the tree. It seems obvious, but the big gorilla doesn't know what obvious is. If you don't use if, the computer might try to peel a green banana, break its nail, crash the system, and the screen will turn blue, and it can get even more complex. There's also else if. If the banana is yellow, peel and eat it. Else if the banana is brown, make a cake. Else, or if that doesn't fit any case, throw it in the trash. This is the decision tree of life. A programmer's life is all about predicting the future. What if the banana is rotten? What if there's no banana? What if the banana is actually a disguised snake? The more if statements the monkey plans for, the fewer bugs he creates. And a bug is nothing more than a situation the monkey forgot to anticipate. The monkey learned how to eat a banana. Great. But now he found a bunch of bananas in the list. What does he do? He writes the recipe 500 times. Take banana 1, peel it, eat it. Take banana 2, peel it, eat it. That's the work of a dumb monkey. A smart monkey is lazy. That's why loops exist. Repetition. You tell the big gorilla, while there are bananas in front of me, repeat the action of eating. We use while and for loops. For each banana in the box, do the same action. This is where the computer beats the monkey. The monkey gets tired at the 10th banana. The computer can eat 1,000,000 bananas in milliseconds without sweating. Programming logic is here for one reason, to make boring work automatic. If you're doing the same thing by hand more than once, you're not programming efficiently. Let GorillaBot do the hard work. You just give the orders, but watch out for the infinite loop. If you say, while I'm alive, eat bananas, and forget to tell him to stop for water, GorillaBot will eat until he explodes or crashes your browser. The power of loops requires responsibility. Before we finish, the secret weapon is still missing. The monkey realized that every day he needs to peel bananas, crack coconuts, and get water. Is he going to write these instructions every single day? No. He creates a function. A function is like giving a nickname to a set of tasks. He creates the function breakfast. Inside it, he puts peel banana, crack coconut, and get water. Now, when he wakes up, he doesn't need to say the step-by-step instructions anymore. He just yells, run breakfast, and GorillaBot does everything on its own. This is programming. It's creating mini robots that work for you. Variables, lists, conditionals, loops, and functions. It may seem simple, but with these 5 tools, people have built rockets, social networks, and even the video you're watching right now. It's all bananas, boxes, and decisions. The beginner monkey's mistake is trying to memorize the code. He tries to remember where to put semicolons. He wants to memorize tricky commands. It doesn't matter. Syntax changes. Today it's Python, tomorrow it's JavaScript. Later it could be GorillaScript. But logic is universal. A banana is a banana, here or in China. So stop acting like a parrot that just repeats code. Start thinking like a true banana architect. Understand the problem, break it into smaller pieces, put each piece in a box, make decisions, repeat. This is how you master the machine. If you don't learn the logic, you'll just be another monkey, pressing random buttons and hoping a banana falls from the sky. And just to be clear, the banana doesn't fall by itself. If you want to learn how to control GorillaBot, subscribe to the channel, leave a like, and keep training your logic. Click the video on the card now to keep learning the right way instead of just watching technology go by. Thanks for watching Banana Code. See you in the next video.